Now, ratio is something you have learned in primary school, right? I have to say, one way that you all do it is you have learned that ratio is used to compare two numbers. Okay, can you all give me some example of what is ratio? 1 to 2. Do we say 1 to 2? 1 is to 2, right? In English, we say this, but how do we represent it in mathematics? Okay, 1 semicolon 2. What does this 1 semicolon 2 actually mean? 1 divided by 2, are they equivalent or are they equal? Equivalent. Okay, so this is equivalent to 1 over 2. Can I say, is this equivalent to 2 over 1? No, right? There is a certain order when it comes to ratio. When we say 1 is to 2, we strictly mean 1 is to 2. We don't say 2 is to 1. And this would mean 1 over 2. Okay, can you see the order? Left to right, up to down. Okay, can? So you have learned this in primary school, and can you all name me some real life examples where ratio is needed, where you need to use a bit of ratio? Yes. What? Baking. Why baking? Why baking need to use ratio? Oh, sorry, so sorry. I'm so sorry. Yeah. Okay. Why? One part of something to two parts of something. You want to try to balance out, let's say the flour and the chocolate needed. Okay, so in baking is needed. Why? Because sometimes the recipes given to you is made for, let's say, 4 people, right? But you are baking not just for 4 people. Let's say you need to bake for 20 people. Then how? Times what? Times 5, right? This is where ratio comes into play. You can use ratio to help you manipulate how much flour you need, how much sugar you need, how much chocolate you need. What else you want to put? What rainbows you all need? One rainbow sprinkler. You all don't know. You all got watch Powerpuff Girls before? I pour in something and pour in something. Yeah, it's something like that lah. Okay, but nah, you're not going to get Powerpuff Girls. Okay, but yeah, so ratio is actually used in that. Okay, so baking is one example. What else? You raise your hand? Is it? Oh, okay. What else? Yes. Sorry? Science experiments. Okay. What kind of science experiments you need to use ratio?
Like when you need to measure certain chemicals.
Measuring of chemicals. Why you don't want to measure?
It will affect the experiment.
It will affect experiment. Okay, so ratio is used in experiments, as what you said, to kind of make sure the reactions go as what it's supposed to do. If you put too much of something, you might cause an explosion. If you put too little of something, it will just become nothing, right? One day you will do crystallization in science, if I'm not wrong, or have you all done it? Okay, crystallization needs to meet a certain amount of requirements, right? You cannot over put some things. You need to balance the amount of water with the amount of chemicals. Okay, I'm not a science person. Okay, so please don't ask me anything about science. But yeah, thanks for sharing for baking and science. Can I get both of your names? Sorry? Jotsa. Okay, I need to. Okay, I'm very bad at names. Jotsa. You? Yue Yang. Okay. Wow. Jotsa Yue Yang. Okay, can. Okay, so any more? Any more? Try to think. Any more? Somebody said something. Any more? Any more examples? So y'all. Okay, the examples that y'all can think of is quite relevant to y'all, right? Okay, out there, let's talk about the building of a school. All these pillars that you see, made of what material? Cement. Is it? Somebody said cement, right? Now, cement, you need to balance the amount of cement and water, right? And it comes in a ratio. It's very much needed because if you put too much water, it cannot solidify. Or when it solidifies, it will crack. You cannot put too little water because they won't even solidify. That's where ratio comes in. Okay, you may think, why must I build stuff? Not necessary. I tell you, building stuff is actually very fun. Be able to do cementing and everything is very, very fun. Okay, I suddenly thought of something, but I forgot my train of thoughts. Okay, there's another application where you need ratio. I suddenly cannot think of it. Just now I forgot. Okay, never mind. I'll tell you when I remember. Okay, but yeah, building of a building is very important. When I make Gundam, like plastic model kits, if I want to customize myself by adding on things, right, I also use this certain material which is very similar to cement to kind of like balance the water with the material, then try to make it into plastic. Yeah, so that's why I use ratio also. I use a bit of ratio, put on a weighing scale, measure, and so on. Yeah, so ratio has many applications and many relevance to other things as well. Now, so I will actually write down the examples for y'all. Y'all can think about it. But is ratio just restricted to comparison of numbers? Because in primary school, you've learned that we compare two or more numbers, but is it only, can I only compare numbers? Can I compare other things? Okay, I want you to think about it. Can I compare other things? Can I compare your height and your weight? No? Can I compare your height and the height of an elephant? Can I compare my ability in mathematics and your ability in mathematics? How? You nod your head, you must tell me how. Huh? IQ test. Okay. Can I compare your gaming ability versus your gaming ability?
Yes.
How?
The amount of time taken to actually complete a level.
Okay, very good. Okay, time taken. Now, can I also compare your musical talent and my musical talent? But how? Yes? Okay, so in life we use ratio to compare a lot of things. We are not just restricted to numbers. We can actually compare quantities. And we realize that just now all the examples I asked, for example, testing mathematics ability, you use a test to be able to test our mathematics ability. That's a quantity, right? We use quantities to kind of see where we go. Now, gaming ability, they say take the time taken to complete a level. That is also a quantity in itself, right? Time is a quantity. So you realize we're actually not just comparing numbers, but we are comparing two or more quantities in life. Okay? Let me just quickly write this down. We are actually comparing two or more quantities of the same kind. This is the most important, that either have or do not have units. Okay, sorry, it's a bit lengthy, but yes. Okay, sometimes I'll get you all to write stuff. Writing stuff ensures that you can remember a certain concept. Okay, one good way to illustrate this example would be if you look at math scales. They always say 1 cm is to 1 kilometers, for example. That is comparing two quantities, right? They may have different units, but you can still compare the quantities. 1 cm to 1 kilometer. But just now I said, can you measure height and weight? Can you compare height and weight? Cannot, right? Because technically the quantities are slightly different. It's not of a good measure to put them in comparison. Okay? So identifying what to compare is very important. Distance is easy because cm, kilometer is fine. They may all be all different units, but you can convert them to be the same units. Right? So always be mindful of what you're comparing. Okay? This is where I need to talk about is when you always see questions, and most students always struggle, is when they see these kind of questions, what is the thing that you're comparing? What is the question asking you to compare? The number of people attending a party, the number of drinks the person drink, the time taken for that person to travel to this location. Okay, it's very important to always identify your subject that you need to compare. Okay? A bit boring lah, but sorry, deal with it. Alright, so very simply, if you look at your textbook for practice noun 1, you will see 2 examples there. Very, very simple example. I'm not even going to spend time with it. Okay, it's an example on lemons and pears. I do not know why the textbook asks for lemons and pears. I don't like lemons. Why would you have 33 lemons? Why would you buy so much lemons? Can somebody tell me? Lemonade. Yes, for that. But lemons are sour. Okay, but actually I like sour stuff lah. But for no reason, why would you buy so much lemons? Okay, so there are 33 lemons and 20 pears in a certain basket. We are supposed to find the ratio for part 1, the number of lemons to the number of pears. Quite simple, right? You can straight away write your answer, which is
33 to 20.
33 to 20. Okay, so this is what it means to be your ratio, and we are comparing 2 quantities. One is the number of pears, one is the number of lemons. Alright? Now, part 2 is we're going to compare the number of pears to the total number of fruits. Can you see that the condition is very important? What you're comparing is so important, and this will carry you throughout to Sec 4. Okay? Knowing your subject is very important. So, part 2, the number of pears is 20, right? The total number of fruits is 20 plus 53, 20 plus 33 give you 53. So this is just a very simple example of ratio, right? And thankfully for us, do I need to simplify the ratio? Is there a way to simplify this ratio? No need, right? Because there's no way to simplify it. Yeah, then let's leave it. This comes to a point where when you put things in ratio, you always need to simplify to its simplest form. Okay, exam tip, if you don't simplify into simplest form, sorry, you won't get the mark, even though your ratio is correct. Okay, I have students lose mark because of this before. They never simplify, but if it's the simplest form, it's fine. Okay, so as what some of you said just now, we can express ratios as fractions. And we call them equivalent fractions. And, fractions, we have equivalent fractions, right? And because ratios can be equivalent to fractions, we also have equivalent ratios. You may not understand what I mean, but let's look at this example. 6 over 18, 3 over 9, 1 over 3, are they equal? Yes. They are all equal. Since they are all equal, we call them equivalent fractions. But all fractions can be converted to ratio, right? So when I convert all these 3 fractions into ratio, can I have equivalent ratios, 3 sets of equivalent ratios? Okay, let me just write it down to show you. Oh, actually it's there already. Yeah, 6 over 18, 3 is to 9, 1 is to 3. Right? All these are equivalent ratios. So you can do that for ratios as well. Okay, you can do that for fractions, you can do that for ratios, as long as you get the order correct. Alright, I'm not going to touch much about this. Okay, I will show you very quickly how to simplify such examples. The first step to always simplifying like numbers, fractions, or anything is to make sure they are integers. What is integers? Quick fire. What is integers? 3, 2, 1. What is integers? Huh? Whole number. What is integers? 3, 2, 1. No, right. What is integers? 3, 2, 1. Okay, no, I'm just kidding. Okay, you see, our human minds cannot work under pressure. Okay, I like quick fire rounds because I want you to think. It's not about you answering, but I want you to think to answer. So somebody said it's a whole number, right? He is not entirely wrong. He's not entirely. He's not entirely. He's quite correct. Okay, integers are mostly whole numbers, except for 0. Okay, but integers can also have negative. We can also have negative integers, correct? Yeah. So let's get some concepts right. Okay. So we will always like to convert this into integers. So do you all know to convert fractions to integers? Don't know, right? Okay, that's where I come in. Now the first step is to always convert it to improper fractions. So this would be 5 over 3 is to 5 over 6. Okay? So this is still in ratio. The two fractions are in ratio. The next step is to ensure that the denominators are the same. How to ensure that the denominators are same? Which is the lowest common multiple. So the lowest common multiple between 3 and 6 is 6. Okay, quite fast. So to make sure 5 over 3 becomes something over 6, I multiply 2 to the top and bottom, and I will have 10 over 6 is to 5 over 6. Okay, you realize I don't have to change the right side sometimes. And this case, I don't have to change the right side. Alright? The next step is, because the denominators are the same, you can multiply 6 to both sides to kind of remove the denominators. Okay? So what I'm doing in green and red is the idea behind. When you multiply 6 to both sides of the ratio, you will only have the numerators left, which is 10 is to 5. And finally, you can simplify this. 2 is to 1. Okay? So the answer here is 2 is to 1. Am I explaining in a way you all can understand? I mean, some of you might have learned this before, I understand. So, but I'm just repeating just in case. Okay? Next, for decimal numbers, is even simpler. How to make them an integer? How to make decimal numbers integer? Times, for this case, times 100 to both sides. Sometimes times 10, sometimes times 100. But you realize one thing. If I multiply 6 to this side of the ratio, I multiply 6 as well to the right side of the ratio. But for this case, why I times 2 here, I don't need to do the times 2 here. Raise your hand, please, if you want to say something. Come. Don't be shy. I ask you to raise your hand, you all don't want to say anything really. Why do I not need to do the times 2 here? It's just converting 5 over 3 to an equivalent fraction, right? Okay, so you must understand the idea here. Alright? Next, so we come to here. What I'm going to do is I'm going to multiply 100 to both sides of the ratio. And I'll have 12 is to 56. See, immediately becomes an integer. I will not, if you have decimal numbers remaining in either side of your ratio, you are still wrong. I have a student who gave me 2 is to 1.5, straight away 0. I'm sorry, because ratios must only be in integers. Alright? So this will simplify to 3 is to 14. Quite straightforward, nothing too challenging here. Right? It's just the manipulation of ratios or quantities that I give you.